The A320 pneumatic system supplies high-pressure air for air conditioning, wing anti-icing, water pressurization, hydraulic reservoir pressurization, engine starting. High-pressure air can be supplied from three sources: the engine bleed system, the APU, and external high-pressure ground power unit. The pneumatic system is controlled and monitored by two bleed monitoring computers, BMCs. There is one bleed monitoring computer for each engine bleed system. Both bleed monitoring computers are interconnected, and if one fails, the other takes over most of its functions. There are air leakage detection loops installed in the vicinity of the hot air ducts in the fuselage, wings, and pylons. If a leak is detected, a signal is sent to the bleed monitoring computer, which automatically isolates the affected area. Bleed monitoring computer number 1 protects the left wing, number 1 engine, and the APU. Bleed monitoring computer number 2 protects the right wing and the number 2 engine. Should number 2 bleed monitoring computer fail, number 1 will take over all its functions, except for the pylon. Should number 1 fail, number 2 will protect all but the number 1 pylon and the APU. Air is bled from two compressor stages of the engine: the intermediate pressure, IP port, and the high pressure, HP port. There is a high-pressure valve which can cut off bleed air from the high-pressure port. It is automatically controlled by the system. The high-pressure section, HP, is only used when there is insufficient pressure from the intermediate output, IP, that is, when the engines are at idle. Once the engine speed is high enough, the IP intermediate pressure is sufficient and the high-pressure HP valve closes. The air extracted from the compressor then goes to a bleed valve, which acts as a shutoff and pressure regulating valve. Since the temperature of the bleed air is high, it passes through a pre-cooler before being distributed to the users. The pre-cooler uses cool air from the engine fan to regulate the temperature. Engine 2 has an identical bleed system. Both systems are connected by a cross-bleed duct. A cross-bleed valve permits their interconnection or isolation. The APU can also be used for bleed air supply. This is usually done on the ground for air conditioning and for engine start. However, APU bleed air is also available in flight. APU bleed air is controlled by the APU bleed valve, which operates as a shutoff valve. Should the APU not be available, a high-pressure ground power unit can be connected. This completes the pneumatic system. We will now show you how system information is displayed to the pilots. Information on the pneumatic system is displayed on the lower part of the ECAM bleed page. Note, we have shaded the upper part of the ECAM bleed page because it is related to the air conditioning chapter. This will be covered in a later module. Let's identify the system components on the ECAM page now. The intermediate pressure and high pressure ports, the high pressure valves, the engine bleed valves, the pre-coolers, the APU bleed valve, the cross-bleed valve, the high-pressure ground connection. The following information is also displayed: bleed air pressure, bleed air temperature, engine identification numbers. Controls for the pneumatic system are part of the air conditioning panel located on the overhead panel. Again, we have shaded those controls which belong to the air conditioning chapter. Each engine bleed valve is controlled by its associated push-button switch on the air conditioning panel. The APU bleed valve is controlled by its associated switch. The cross-bleed selector enables the pilot to open and close the cross-bleed valve manually or to let the system operate the cross-bleed valve automatically.